Hey, what is going on, guys? This is CodedSteele, and welcome to another App Inventor tutorial. Our first actual practical App Inventor tutorial. So if you guys remembered, a few of the videos we've done, or I've showed you, the App Inventor interface, how to do a few simple things, and then also how to build a login screen. Well, this is actually the first time we're going to do something that's actually practical and could be useful. So, like I said, it's going to be an Ohm's Law calculator. And for any of you guys that don't know, it's a useful tool for anybody in the field of electrical engineering or anybody in a technical field where you deal with electricity on a daily basis. So, this is actually a pretty powerful little application, and obviously we can go much more powerful than something like this. But this is a clear example. And it'll actually paint a pretty good picture in your guys' head about what you could actually do with this interface to actually make something useful for whatever application you may like to use. So the application that it's in front of us right now is what we're actually going to build. Rather, this is just the designer portion, and then we have the blocks portion, which is relatively complicated. You guys can see it there's a little bit to this one compared to other ones that we've done, but nothing we can't handle. I'm going to show you guys an example of what this thing is going to be able to do when it's built, and then I'm going to actually go through and I'm going to show you guys how to actually build it. So here it is. I'm running it in real time right now on this emulator, and I have the voltage column highlighted. So I'm going to type in maybe a standard voltage that you guys are used to. I'm going to type in 12 volts. Which is electrical standard. Usually you see, 1.8 volts, 3.3 volts, 5 volts, 12 volts, 24 volts, maybe 18 volts. Kind of uncommon, but usually it goes straight from 12 to 24. And then you got other voltages that are much higher. Those are the common DC voltages. And then you got other voltages that go higher than that. But anyways, that's not the point of this tutorial to describe voltage potentials that are common. We're going to input 12 volts, and then I'm going to input, I'm going to actually put in, we have a resistance actually of 1,000 ohms. So a 1 kilo ohm resistor. And then when I hit this calculate button here, which I can either do, you guys are seeing me actually enter it in from the keyboard now rather than from the tablet. I can actually punch the calculate button here. And voila, you can almost kind of do that one in your head. It gives you the answer of 0.012 amperes. So it lets you know, okay, I have 0.012 amperes of current that are being drawn through a 1 kilo ohm resistor. So, and then I can hit this clear contents button and do a new calculation. I could do 5 this time, and then I could say I want 1 milliamp maybe, 0.001. Okay, why is it not taking my decimal? How about that maybe? There we go. I don't know why I wasn't taking that when I did it from there, but whatever. And then calculate, and we get 5,000 ohms. So you guys can see that the application is clearly working. We can check that on a calculator, and you can see that it is indeed 100% correct, 5,000 ohms. So now that's kind of exactly what we're going to be building. But how do we build something like this? How do we get to the point of building something like this? Well, that's what we're going to do now. I'm actually going to take you guys through the steps on how to build something exactly like this. So I'm going to go ahead and we're going to say start a new project. And I'm going to actually call it Ohm's Law. Alright, okay, you don't like that. How about Ohm Law? Is that okay? Alright, that seems to be okay. Cool, passes. Alright, so we're going to get straight to this, and then I'm going to have to give you guys an introduction to procedures. I'm hoping that I can get through this all in one video. I might not be able to, so I might have to split this into 2 videos, but no big deal. We will get through it no matter what. So, alright. First thing we're going to do, as you guys might have seen, we're going to go to the layout layout area. We're going to drag one of these in. And I'm just going to switch it quickly to a 3 by 3 columns and rows. And then we're going to go back to our layout. This is all, or sorry, not layout. This is all stuff that you guys, we should have done another thing here in layout and did a horizontal arrangement. Go back to the user interface. So just kind of do what I'm doing here. You guys probably almost know what, or should know what to do by now. you know, how to drag in buttons and do all of that crazy stuff, I'm sure. So we're just going to drag in some labels, drag in another label. Oh, not an image. A label. There's another label. And then there's our third label. Alright, and then we're just going to drag in a few text boxes. Why am I not seeing that? There it is. So just drag in a text box, drag in another text box, and then drag in another text box. What? Why does it not seem like it took my third text box? There we go. Now it did. That was crazy. Alright, and then I'm actually going to drag in, this is something else, I'm going to make a on-the-spot addition to the app. And I'm going to add these other labels, and you'll see what they're there for in a minute. Alright, we'll drag those in. Cool. Alright, then, just like I've done every other time, I'm going to modify them to useful things so we actually know what each of these entries are for. So voltage, current, and of course resistance. Common electrical parameter stuff dealing with here. Nothing mind-boggling, I'm sure, for anybody who understands these parameters. And if you don't, it doesn't matter. It's not like a requirement for you guys to understand this stuff for the app in order to be able to follow along. Gosh, I don't know why I could not think of what I was saying. And then just say calculate. And this is, like I said, just mirror image of what I was doing before. Calculate, and then just to clear contents. So when that's clicked, obviously, self-explanatory, it'll clear everything in the fields, and when calculate's clicked, it'll calculate whatever the empty text box is, calculate out its parameter. Alright, cool enough. The other thing we're going to do, we have to go back under the Layout tab, and I'm going to add in another thing here. Let's see, we want this, right? Yeah. I want to go ahead and add in a label. Okay, cool. Alrighty. Horizontal arrangement. Yeah, I can't get that centered yet. So you guys can see right here on my other thing that I had here. Whenever you go, if I went back to the other application, the other thing that I had was it had Ohm's law centered. Well, you can see clearly that we're actually not capable of doing that. These are actually grayed out. How do we make that possible to where we can actually center that? Well, what you actually have to do is you have to go under the screen, or sorry, you have to go to the actual horizontal arrangement and switch it from automatic to fill parent, and then click OK. And the reason why it does that is because when you say automatic, it is assuming that it's scrollable. And when it's scrollable, the text will shift, will stay where it's at on the screen, and move with the screen. So when we said automatic before, it will shift it actually all the way down to where this box meets up with the label, and it will not go any further. So that's just something that App Inventor does as to not take up space. And the other thing, like with a line vertical, I'd have to switch height to fill parent. And if we did that, though, it would actually bump all that information down. So obviously we don't want that to happen. But now, as you can see, I hit the fill parent for the width, which is okay. That's what we want, actually. And then I can center the label. So that's something new. That's why I actually took the time to sit there and describe that to you guys, how that's actually done. And then we can just shift the font, which is another new thing I don't think I taught you. You just click on a cell and you input your stuff. Pretty simple. And then we're going to bold the font. And then we're going to go ahead and change the label. And it's just going to simply be V equals IR. Which, for those of you guys who know, that is Ohm's law. V equals IR. Cool enough. And it might not look, just so you guys know, it might not look exactly like it did before with my other thing. I might have a few different things, which if I do, you know, I can't remember exactly, you know, what I did per se. I mean, it was kind of kind of something that I just did to make it look. Maybe that was what I used for the font. I don't know. You guys can go back to the beginning and maybe try to experiment until you figure out which one it is, or just follow along with what I'm doing. Whatever. But as you guys can see now, the user interface is pretty much done. I mean, there's really nothing else we need to do. Well, scratch that. There is a few more things that we need to do here in the user interface stuff just to make the blocks programming a little more user friendly. But that's the bulk of the user interface. It's all summed up. Just a few more things I'm going to do real quick is I'm going to click on these text boxes and I'm going to change the actual name of the element. And the reason I'm going to do that is because if I don't, text box 1, text box 2, text box 3, I don't really know what those mean in where did this one go? I don't know. That one must have went somewhere in like free space. I couldn't see it. And then let's see, we got to change this name. Anyways, I think I lost track of what I was saying as far as what I was saying, or what I was no, not hint. Oh gosh. Rename current. Okay. Alright, cool. And then rename and resistance. Okay, sorry, I kind of lost track of what I said there for a second, just because I'm trying to get my stuff squared away here. To eliminate the hints, so there's nothing in the box. I don't want anything. Hints are good. You guys kind of know what hints would be good for. Maybe for your password. In your login interface, we maybe could have added a hint and said, you know, set the hint to this so they know what their stuff is, and you could have that in the box. I don't really see a point to doing that, obviously, for this type of thing. So that's why I eliminated that out. And then we just got to rename these buttons. Oh no, text was fine. Why did I screw that up? Calculate. I wanted to rename the button. I'm just going to name the button to calc. And then I'm going to rename clear contents just to clear. Okay. Anyways, to finish what I was saying before, the reason I'm doing that is because when I get to the button interface, and maybe I explained this already before, but sorry, I'm going to explain it again because I don't remember if I did. But when we get to the blocks interface, and we're actually going to go there now because we're completely done with this area. So I'm going to go here. If you go to the interface here, we can clearly see, boom, there's our stuff, our information, voltage, current, resistance. Text box 1, text box 2, and text box 3 are what would have appeared here before. And I don't know what those ones are. I might not necessarily know. And especially if I got a really long program with a ton of stuff going on it, if I don't name the box to something that I actually know what it is, it's going to kind of mess me up when I'm actually going through and making a useful application for somebody. So that's why I changed it. So those are it's obvious what those actually are. I'm sure you guys understood that and it kind of made sense to you, but I explained it anyway. All right. So now we need to add the functionality to this program here. And if you guys remember, I was going to introduce the procedures base here. So, wow, what am I gonna do for that? What are we gonna do for procedures? Well, we're gonna go to the procedures block here, these are purple blocks, and we're going to drag in one of these two blocks. Which one? Well, they both have different uses. This procedure right here is a procedure, and it actually will tell you right here with the text, does not return a value. Okay, maybe you don't know what returning a value means, but I'll explain that in just a second. And this one you can see returns a result value. Okay, a procedure, if you guys are familiar with programming, a procedure that does not return a value is the equivalent of typing void in front of a function name. When you're creating a function name, you type in the word void. That is exactly what a procedure that doesn't return a result is doing. You're saying void, meaning I just want a function that's going to do this and it's going to do some stuff, but I don't want it to give me a value back. I just want it to perform that action, and then after that action's performed, I want it to just go away and we'll move on with the program. Well, a result could be useful for a number of reasons, and the reason we're actually going to use it for this time is to return a mathematical operation. So that's something that you usually would use a result for. If you wanted to return a mathematical operation, like maybe you wanted to create a function that just does multiplication, division, and subtraction, or something along those lines. Well, you wouldn't want something maybe that's void, because if you want to get the variable back in your main loop and display it, you need it to return some information to you. So that's the reason we use procedures with results. There are other ways that we could do it, like global variables and stuff like that, but global variables get a little messy because a global variable can be accessed by anything in your program. And sometimes that's not desirable, because maybe if you have a bug in your program, you can't figure out exactly what's going on. Maybe it is somehow calling a variable that you don't want it to be able to call. So we can use actual local variables within a function to eliminate the potential for other functions being able to call the global variable. So that's where procedures would come in handy. Is we don't want anything to muck up with our other variables that we have in the program. But anyways, procedure here. I said we're going to bring two of them in. Well, what we actually have to do too is we have to create inputs, and I will explain what input stuffs are in just a second after we drag this stuff in. Each of them are going to have two inputs. I probably would have been able to, might have been better for me to copy them and do this afterwards, but it's not that big of a deal. Just change that to x, y, x, y, x, y. I'm not going to name them anything clever. So those are our variables set, and then we're going to rename the procedures to what they're going to do. This one is going to calculate the voltage. This one is going to calculate the current. Okay, and you better capitalize it, stay with convention that I'm doing through the whole thing, and then this one will calculate resistance. There we go. Okay, so I have these x and this y. What the heck is going on with those? Well, what is actually going on, and I'm going to grab both of these x and y's out of here, and we're going to copy, paste, paste, and then copy, paste, paste. Alright, so you guys might be wondering, what the heck is going on here? What are you doing with all of this stuff here? Well, we are going to pass in the parameters from our text boxes into those variables. I'll show you guys how we're actually going to do that in a second. But anytime you want to pass things from your main loop, your main program loop, to a procedure, you have to create what are called inputs in here, but you can think of them as variables in like a C program or Java programming language. They're basically, yes, they're variables. So I'm pushing that information into this procedure here. I want this information to come into these procedures. All right, so I'm not going to explain the math behind how Ohm's law works. You can Google it, or maybe watch one of my tutorials that I've made about electric circuits, which is in another on my page. You can just look for stuff where I talk about intro to electric circuits, and I explain Ohm's law there. I think in a pretty easy to understand way, to where anybody who has no prior electronics experience can understand what is being said. So, but like I said, I'm not going to explain the math here. All I'm going to do is just say, do exactly what I do here. I'm dragging in a multiplication sign, I'm dragging in a division sign, and then I'm just going to copy this division sign. Alright, and then here, we're going to go ahead and drag x and y into here. Oh, come on, drag it into there, and then just drag that into the procedure. Done. Alright, and then here, do that, do that, do that, and then do that, do that, and then do that. And that's actually all we're going to do for our procedures. You can create procedures that are way, way more complicated than this, but here's the thing with procedures. The reason you use a procedure is to organize your program. So if you are going to have a main loop that's maybe going to go through and do a bunch of processes, sometimes, and we can add comments to our code, which I don't think I've showed you guys how to do. You can just right click on the block and say add comment, and it will allow you to actually add a comment to your thing under this question mark. I can just type in, calculates voltage. I don't know, something like that. So now, anytime I click on the comment, it'll tell me what that does. So although we can add comments, sometimes it's handy for us if we have stuff divided into blocks with clever names. We don't actually have to click on these question marks to understand exactly what they do. And then on top of that, if we also create working blocks that we know, like say we create a function and we've tested that function and we know that function works, then we know if there's a bug in the program that it's not this function that's calling it. So I'm going ahead through and I'm creating a program, la-di-da-di-da, I'm punching a bunch of stuff on a keyboard, and I go through and I complete a completed program. I create a whole game and I crack it out in an hour. All right, I go back through and then I actually try to play it and I realize there's a bug. Something's not working the way it's supposed to work. Well, why isn't it working? If my program's not organized into procedures like I'm doing over here, maybe it's not so obvious what is actually wrong with the program. So that's kind of why I made the decision to add procedures to this. Now, granted, these procedures are so low level that it's not even, you wouldn't even have to maybe do this. But if you're creating a program and you're going to have a lot of things going on, maybe you want to create if for a game, you want to create a movement holder or an XY location holder for a sprite or something that we'll talk about sprites later. I haven't talked about sprites. If you guys don't know what they are, don't worry about it. We'll talk about it later. But if you want to create a movement holder for a sprite, maybe you have a function that does all the movement handling for a sprite, and you have that in the main loop, maybe that's like 5 or 6 different processes it goes through to calculate where that sprite will move. If you run into an enemy, maybe there's some knockback. Okay, maybe that can all be handled in a sprite movement calculator. And if you have a bunch of stuff going on in a function, you don't know where exactly that movement handler stuff is taken care of. That's why creating a procedure can actually help you organize stuff. So that's a very lengthy explanation to why you would need to use procedures, but hopefully you guys thoroughly understand exactly what's going on now. This video is starting to get a little long, so I think I'm actually going to wrap it up now. Next time we definitely will finish the remainder of the program. All the guts of it are done, the user interface. The actual math is all done and taken care of for us. We don't even have to do anything with that anymore. And then next time we'll finish up all the button pushing and the text entering and all of that good stuff. So, actually, you know what? No, one more thing we're going to do before this is done, because I want to get this out of the way for this. And I'll explain why we do it next time. We're going to click on voltage and we're going to click numbers only. And then we're going to click on current and we're going to click numbers only. And then we're going to click on resistance and we're going to click the numbers only blocks over here. As to why we did that, don't worry about it. If you don't understand, I will explain it in the next video as to why those were selected. But anyways, until next time, please like, comment, subscribe, watch other of my tutorials, pass this on to your friends, and I will see you guys in your next App Inventor programming tutorial.